June 19, 1944. 0800 hours. Western Philippine Sea. IJN Taiho steams into wind preparing to launch aircraft. Admiral Jisaburo Ozawa's flagship. Japan's newest carrier. Most advanced, most heavily armored. Built to survive anything. 3 months old. First combat mission. Flight deck crew positions aircraft. Engines warm. Propellers spin. Checklist complete. Launch in 10 minutes. Below the waterline. USS Albacore has maneuvering solution. Lieutenant Commander James Blanchard watches through periscope. Range 5,300 yards. Carrier turning. Launch sequence starting. Aircraft moving on deck. Perfect target. But torpedo data computer malfunctions. False readings. Blanchard makes decision. Fire all 6 bow tubes. Maximum spread. Maximize hit probability. Trust mathematics. 6 Mark 14 torpedoes sprint toward Taiho. 46 knots. Each carries 643 pounds of Torpex high explosive. Each programmed to run 10 feet below surface. Each seeking steel hull. The mathematics favor destruction. Warrant Officer Sakio Komatsu sits in cockpit of Mitsubishi A6M0 fighter. Engine running. Waiting for launch signal. He sees something. White streaks. Torpedo wakes. 6 lines converging on flagship. No time to radio. No time to warn. He makes decision. Pushes stick forward. Full throttle. Dives. Aims for nearest torpedo. 0 impacts torpedo at 180 knots. Both explode. Column of water. Fragments. Komatsu dies instantly. Destroys torpedo. Saves ship temporarily. 4 remaining torpedoes miss ahead. 1 continues tracking. Explodes against starboard hull forward of island. Water column reaches flight deck. Shock travels through structure. Aircraft launching sequence stops. Everyone feels impact. Nobody panics. Taiho is armored carrier. Built for this. 1 torpedo is manageable. The damage report arrives quickly. Forward elevator jammed. Locked between flight and hangar deck. Hull penetrated starboard side. Aviation fuel tanks ruptured. Fuel oil tanks ruptured. Elevator pit flooding with mixture. Water. Gasoline. Oil. Combined. Vapor rising, but no fire. Structure intact. Flight deck undamaged. Armor worked. Admiral Ozawa receives report. Studies damage. Makes decision. Continue operations. Launch aircraft. Taiho can fight. Minor damage does not justify breaking off action. American carriers within range. Operation A. Go depends on engaging them now. Maximum strength. Taiho remains operational. She launches second wave. 16 Zeros. 17 Yokosuka D-4Y Judy dive bombers. 9 Nakajima B-6N Jill torpedo bombers. 42 aircraft. They form up overhead. Depart westward. Ozawa radiates confidence. Everything proceeding correctly. Damage under control. This is exactly what Taiho was designed to survive. He is correct. About the armor. About the structure. About the damage being survivable. He is wrong about having it under control. To understand how Japan's most advanced carrier destroys itself, you need to understand what made it advanced. Taiho means Great Phoenix. The name reflected ambition. Japan's treaty with Britain and United States had expired. Naval arms limitation ended. Japan could build without restriction. Could implement lessons from early war experience. Could design carrier matching anything Americans built. Could emphasize protection. Previous Japanese carriers prioritized aircraft capacity and speed over survival. Akagi, Kaga, Soryu, Hiryu, Shokaku, Zuikaku. All unarmored, all vulnerable. 4 died at Midway. June 1942. 2 years earlier, almost to the day, 4 fleet carriers sunk in one battle. Catastrophic loss. Irreplaceable loss. Japan's carrier doctrine died at Midway. New doctrine required survivability. Taiho embodied new thinking. Laid down July 10, 1941. 6 months before Pearl Harbor, designed under emergency program as modified Shokaku, original plans called for 3 ship class. Only Taiho completed. Resources diverted. Priorities changed. Construction dragged. Launched April 7, 1943. Commissioned March 7, 1944. 3 years from keel laying to commissioning. Long by wartime standards, but complex by wartime standards. The specifications. Length 260.6 meters overall. 253 meters at waterline. Beam 27.7 meters at waterline. 30 meters maximum including sponsons. Draft 9.6 meters. Standard displacement 29,300 tons. Full load displacement, 37,720 tons. Heaviest Japanese carrier completed except Shinano, which was converted battleship hull. The propulsion, 8 Kampan boilers feeding 4 Kampan geared turbines, 160,000 shaft horsepower, 4 screws. Maximum speed 33.3 knots. Range 10,000 nautical miles at 18 knots. Fuel capacity 5,000 tons. The power plant matched fleet speeds. Could keep pace with battleships. Could maneuver aggressively. Could generate enough electricity for extensive damage control systems. Ventilation. Fire suppression. Radar. Communications. The armor. Unprecedented for Japanese carrier. Belt armor 55 mm maximum amidships. 25 mm forward and aft. Hangar side armor 25 mm. Lower hangar deck 48 mm. 32 mm armor plate on 16 mm structural steel. Increased to 90 mm over magazines. Flight deck armor 76 mm over 19 mm plating. Total 95 mm between hangar and sky. Designed to stop 1,000-pound bomb. Elevator pits 50 mm. Magazines 165 to 70 mm vertical protection. Fuel tanks 85 to 50 mm protection. Steering gear 125 to 50 mm. Underwater protection included 76 mm longitudinal bulkhead. The total armor weight, over 8,000 tons, 27% of standard displacement. Higher ratio than any Japanese carrier except Shinano, higher than most battleships as percentage. The armor transformed Taiho from floating airfield into armored airfield. This distinction mattered, or should have. The flight deck, 257 meters long, 30 meters wide amidships, varied from 18 meters forward to 27 meters aft. Largest deck area of any operational Japanese carrier, longer than hull, overhung bow and stern. The deck surface was innovation, not wood planking, not bare steel. Latex coating, 6 millimeters thick. Over steel, lighter than wood, cheaper than wood, faster to apply, faster to repair, cushioned landing impact, seemed brilliant, proved problematic. Latex degraded in salt spray, became brittle, cracked, provided poor traction, required constant maintenance, but saved weight, saved construction time. Acceptable trade-off initially. 2 aircraft elevators. Forward elevator 13 meters by 16 meters, capable lifting 6,000 kilograms. Aft elevator smaller, both hydraulically powered, both armored, both critical for aircraft operations, both positioned such that their pits extended below waterline when elevator lowered. This design feature reflected space constraints. Taiho sat low in water. Freeboard limited. Hangar deck near waterline. Elevator pits necessarily extended below waterline. Standard design for heavy armored carriers. British Illustrious class same configuration. American Essex class avoided problem through higher freeboard. Japan could not afford higher freeboard. Would increase displacement, decrease stability, reduce armor. Compromise accepted, risk acknowledged. Countermeasures planned. Pumps, watertight doors, damage control procedures, all designed to handle elevator pit flooding. The countermeasures failed to anticipate one scenario. Elevator pit flooding with volatile fuel mixture. This was the scenario occurring at 0808 hours, June 19, 1944. The armament. 12 Type 98, 10 cm 65 caliber dual-purpose guns in 6 twin mounts, located on sponsons below flight deck level, kept clear of flight operations. Each mount had 300 rounds. Rate of fire 15 rounds per minute. Range 12,000 meters. Best heavy anti-aircraft battery in Japanese Navy. Fire control directors. Type 94 with 4.5-meter rangefinders. 1 director forward of island on flight deck. 1 port side amidships below flight deck. The secondary armament initially 8 triple 25mm machine guns. Increased by June 1944 to 51 25mm guns in various mountings. More added after shakedown. Anti-aircraft defense reflected lessons learned. American air attacks required maximum defensive firepower. The radar. Type 21 air search. Type 13 early warning. Japan lagged in radar technology. Taiho's systems were adequate, not excellent. Detection ranges inferior to American equipment, but present, functional, better than earlier carriers. Fire control radar absent. Japanese never developed effective surface fire control radar. All gunnery optically directed. Limitation accepted. The aircraft capacity, designed for 84, Operational capacity 65. Actual strength June 1956 after losses. 27 Mitsubishi A6M50 fighters. 22 Yokosuka D4Y Suisei Judy dive bombers. 4 D4Y reconnaissance variants. 18 Nakajima B6 and Tenzin Jill torpedo bombers. 3 Nakajima C6N San reconnaissance aircraft. Total 74. 9 lost to operational accidents before June 19, reduced to 65. Then 42 launched during morning. 23 remained aboard. Plus deck crews. Plus maintenance personnel. Plus damage control parties. Plus ship's company. Total 2,150 personnel. The design emphasized 2 things. Protection and command capability. Taiho was built as flagship. Bridge was largest on any Japanese carrier. Multiple plotting rooms. Radio facilities. Code rooms. Staff accommodations for 30 officers. Ozawa chose Taiho specifically for command facilities. Transferred flag from Shokaku April 15, 1944. Worked up with Carrier Division 1 at Tawi Tawi. Taiho, Shokaku, Zuikaku. 3 fleet carriers. Backbone of mobile force. First carriers. Best carriers. Most experienced crews. These 3 would decide Operation A-Go. The operation aimed to destroy American carrier force supporting Saipan invasion. Decisive battle. 1 engagement. Maximum strength against maximum strength. Winner controls Pacific. Loser loses war. Japanese planning assumed rough parity in numbers. 400 aircraft on 9 carriers versus American force estimated at equal strength. Intelligence was wrong. Americans had 15 carriers, 956 aircraft. Japanese would lose, but Ozawa did not know this. He knew he had Taiho, newest, best protected, theoretically unsinkable. Built to survive torpedo and bomb hits. Built to keep fighting. Built to make difference in decisive battle. 3 months old. Finally ready. Finally in combat. About to prove design either successful or flawed. Test would take 7 hours. The torpedo hit occurred 0808. Forward elevator jammed immediately. Electric power failed in forward sections. Hydraulics failed. Elevator frozen between flight deck and upper hangar. Could not raise. Could not lower. Blocked access. Created obstruction, but flight operations continued. Aft elevator functional. Aircraft could launch. Could recover. Ship remained operational. Damage control parties assessed situation. Began repairs. Standard procedures. Everything by the book. Everything correct. Everything that made situation worse. The elevator pit flooded with mixture. Water from hull breach. Gasoline from ruptured aviation fuel tanks. Fuel oil from ruptured bunkers. The aviation fuel tanks were located below elevator pit. Design flaw. Space constraints. Weight distribution requirements. Placing fuel storage low in ship improved stability. Placing it adjacent to elevator well improved refueling logistics. Placing it outside main armor belt saved weight. These decisions were deliberate, made by competent designers, under severe constraints, with incomplete information. The designers knew American and British practice located fuel storage inside armored citadel. Japanese chose different solution. More capacity. Less protection. Different trade-off. Not obviously wrong. Not obviously right. Just different. Until torpedo hits elevator pit. Gasoline is volatile. Evaporates readily. Creates flammable vapor. Vapor is heavier than air. Concentrates in low spaces. Elevator pit is low space. Confined space. Perfect for vapor concentration. Dangerous concentration. Explosive concentration. The mixture in pit immediately began generating vapor, rising into hangar, spreading laterally, seeking lowest spaces, pooling, accumulating, growing more dangerous every minute. Damage control parties recognized problem, smelled gasoline, saw vapor, understood danger, implemented procedures, closed watertight doors to contain flooding, activated fire suppression systems, posted watches, prohibited smoking, eliminated ignition sources. Proper response, but incomplete. They could not stop vapor generation, could not remove vapor fast enough, could not solve fundamental problem. Confined space full of volatile fuel mixture generating flammable atmosphere. Problem required ventilation, massive ventilation, continuous ventilation. Removing vapor faster than generated. This was possible. Taiho had extensive ventilation systems, but using them required understanding risk, required accepting risk of spreading vapor, required choosing between 2 dangers. Explosion from ignition in concentrated area, or explosion from ignition in dispersed area. Choice seemed obvious. Disperse vapor. Reduce concentration. Eliminate explosion risk. Except that proved wrong choice. By 0900 hours, air operations resumed. Aft elevator operational. Aircraft recovered. Refueled. Rearmed. Prepared for subsequent strikes. Normal carrier operations. Deck crews worked. Vapor spread through hangar. Nobody made connection. Nobody recognized ship becoming floating bomb. Deck was undamaged. Structure intact. Systems functional. Everything seemed manageable. The damage control officer was junior, inexperienced. Warrant officer, not incompetent, just inexperienced, lacked seasoning, lacked context, lacked understanding of carrier aviation fuel hazards. He faced problem. Vapor in hangar, spreading, growing more concentrated. Options limited. Could seal hangars. Contain vapor. Risk explosion, destroying sealed compartments. Or ventilate hangars. Disperse vapor. Risk spreading vapor throughout ship. He chose ventilation. Ordered aft elevator lowered. Increased draft through hangar. Ordered ventilation ducts opened in hangar sections 1 and 2. Increased mechanical airflow. Ordered crew to smash portholes with hammers. Increased natural ventilation. Did everything textbook recommended. Everything that seemed correct. Everything that turned entire ship into fuel air bomb. The ventilation systems worked exactly as designed. Powerful fans. Extensive ductwork. Capable of complete air exchange every 10 minutes. Perfect for removing smoke. Perfect for removing fumes. Perfect for removing routine contamination. Catastrophic for removing explosive vapor. Because explosive vapor does not need removal. Needs containment. Needs isolation. Needs starvation of oxygen. Needs prevention of ignition. Dispersal only works if you can disperse below explosive concentration. Taiho's ventilation could not. Too much vapor. Too much fuel. Too confined to space. The ventilation simply spread explosive atmosphere throughout ship. Into spaces previously safe. Into crew quarters. Into machinery spaces. Into passages. Into voids. Everywhere. By 1100 hours, Taiho was saturated. Entire ship below flight deck contained flammable atmosphere. Waiting for ignition source. 1430 hours. 6 hours, 22 minutes after torpedo hit. Something sparks. Nobody knows what. Electrical short possibly. Mechanical friction possibly. Static discharge possibly. Spontaneous ignition possibly. Does not matter. Spark occurs. Vapor ignites. Deflagration begins. Flame front propagates at subsonic speed. Not detonation. Deflagration. Difference matters. Detonation creates supersonic shock wave. Destroys everything instantly. Deflagration creates pressure wave. Slower. Still catastrophic. Pressure builds throughout confined spaces. Seeks release. Finds weakest points. Flight deck. Hull sides. Bottom. Senior staff officer on bridge sees flight deck heave upward. Armor plate. 76 millimeters. Over 19 millimeter structural steel. Lifts like cardboard. Blast pressure underneath. 10,000 pounds per square inch. 20,000. 30,000. Steel yields. Rivets shear. Welds separate. Deck buckles. Sections lift. Break loose. The armored flight deck designed to stop 1,000-pound bomb cannot contain explosion from below. Armor is directional. Protects against external threats. Useless against internal pressure. Design assumption violated. Ship destroying itself from inside. Hull sides blow out. Both sides. Multiple locations. Frames 60 to 80. Longitudinal structure fails. Plates separate. Ocean rushes in. Flooding begins. Uncontrolled flooding. Massive flooding. Progressive flooding. Forward. Amidships. Aft. All sections. Water enters faster than pumps can remove. Ship begins settling. List develops. 2 degrees. 5 degrees. 7 degrees. Systems fail. Electrical fails. Hydraulic fails. Steam lines rupture. Pressure drops. Propulsion stops. Taiho loses power. Loses steering. Loses way. Dead ship. Sinking ship. Ozawa on bridge watches flagship dying. Wants to go down with ship. Staff refuses. Prevail upon him. Admiral must survive. Must command remaining forces. Must continue battle. Must transfer flag. Ozawa yields. Takes Emperor's portrait. Sacred object. Cannot be lost. Must be saved. Destroyer Wakatsuki pulls alongside. Difficult. Taiho listing. Settling. Wakatsuki maneuvers carefully. Transfers Ozawa. Transfers staff. 26 staff officers. Moves to cruiser Haguro. Ozawa's new flagship less comfortable, less capable, but floating. Taiho is not. 1432. Second massive explosion. Aft magazines. Fuel storage. Ammunition. All ignite. Blast larger than first. Ship breaks. Keel fractures. Structure collapses. Everything burns. Men jump overboard. Hundreds. Thousands. Water full of swimmers. Oil on water. Oil burning. Men swimming through flames. Destroyers recover some. Most drown. Most burn. Most die. 1628. 6 hours, 20 minutes after torpedo hit. 8 hours, 20 minutes after beginning day. Taiho sinks stern first. Goes vertical. Bow rises. Pauses. Slides backward. Disappears. Position 13 degrees 12 minutes north. 137 degrees 39 minutes east. Depth approximately 5,500 meters. Wreck never located. Too deep. Too remote. Lies there still. Greatest Japanese carrier. Newest. Most modern. Most protected. Most advanced. Lasted 3 months. First combat mission. Last combat mission. Same mission. Casualties, 1,650 officers and men. From complement 2,150. 77%. 500 survive. Rescued by destroyers, including Ozawa, including staff, including some crew. Most die. Most of aircraft gone. Launched earlier. Never return. Nowhere to return to. Land elsewhere. Ditch. Captured. Lost. Taiho's air group destroyed without enemy engaging it. Without American fighters shooting them down. Without American flak hitting them. Destroyed by logistics. By their carrier sinking. By losing mobile base. This is carrier warfare. Ship dies. Air group dies. Both inseparable. The battle continues. Taiho's loss unknown to Americans initially. Codebreakers lose track of her. Wonder where she went. Assume damaged. Withdrawn. Do not know sunk. Prisoner of war reveals truth months later. Blanchard receives Navy Cross. Albacore credited with damaging Shokaku class carrier. Later confirmed as Taiho. 31,000 tons. Newest carrier. Best protected. Sunk by single torpedo. 7 hours later. From damage control failure. From design flaw. From inexperience. From bad decisions. From bad luck. From everything going wrong simultaneously. But Americans did not sink Taiho. Albacore damaged her. Damaged seriously. But survivable damage. Armor worked. Structure held. Systems functioned. Ship remained operational. Taiho destroyed herself. Through cascade of failures. Engineering. Procedural. Training. Doctrinal. All combined. The engineering flaw was fuel tank location. Outside armor belt. Adjacent to elevator pit. Below waterline. Triple vulnerability. Anyone solvable? All three together deadly. American carriers located fuel tanks inside armored citadel. British carriers same. Japanese chose different approach. More capacity. Less protection. Cost less. Built faster. Worked fine until it didn't. Elevator pit flooding manageable. Fuel contamination catastrophic. Design accepted risk unknowingly. Consequence was Taiho. The procedural flaw was ventilation doctrine. Japanese procedure for vapor removal emphasized dispersion. Spread vapor. Dilute concentration. Eliminate explosion risk. Doctrine worked for minor contamination. Small fuel spills. Limited vapor generation. Did not work for major contamination. Massive fuel spills. Continuous vapor generation. Doctrine assumed vapor could be diluted below explosive concentration. Assumption required ventilation capacity exceed vapor generation rate. Taiho's situation reversed equation. Vapor generation exceeded ventilation capacity. Dilution was impossible. Dispersion only spread danger. Doctrine failed because underlying assumption failed. Nobody recognized assumption failed until too late. The training flaw was inexperience. Damage control officer was warrant officer. Competent at technical level. Insufficient at analytical level. Could follow procedures. Could not evaluate procedures against situation. Could not recognize when doctrine inappropriate. Could not improvise effective solution. This was not individual failure. Systemic failure. Japanese Navy had lost massive institutional experience. Midway. Guadalcanal. New Guinea. Philippines. 2 years of attrition. Best officers dead. Best petty officers dead. Replacements untested. Taiho's damage control officer was replacement. Doing best with tools available. Tools inadequate. Knowledge inadequate. Time inadequate. Result inevitable. The doctrinal flaw was armored carrier concept. Japanese adopted British idea. Armored flight deck. Heavy side armor. Protection against bombs. Protection against shells. Survivability emphasis? All correct theoretically. All sound engineering. But implementation created vulnerabilities. Armor added weight. Weight reduced freeboard. Reduced freeboard put hangars near waterline. Put elevator pits below waterline. Created vulnerability to torpedo hits. Vulnerability to flooding. Armor protected against air attack. Created vulnerability to submarine attack. Trade-off. Not wrong. Not right. Different. Context dependent. Against American dive bombers. Excellent. Against American submarines. Fatal. Taiho faced submarine. Wrong context. Wrong trade-off. These flaws were knowable. Were predictable. Were preventable. Fuel tank location could be changed. Was changed in later designs. Shinano had fuel tanks inside armor belt. Lesson learned. Too late for Taiho. Ventilation doctrine could be modified. Was modified after Taiho. Carriers instructed to seal compartments with fuel vapor, not ventilate. Lesson learned. Too late for Taiho. Training could be improved. Was improved in later carriers. Experienced officers assigned to damage control. Lesson learned. Too late for Taiho. Design could be modified. Was modified in planning. 5 improved Taiho-class carriers ordered. Never built. Resources diverted. Priorities changed. Lessons never applied. War ended before corrections implemented. Taiho represents Japan's carrier aviation apex and nadir simultaneously. Apex in design sophistication. Most advanced Japanese carrier. Best protected. Best equipped. Best commanded. But nadir in institutional capacity. Built too late. Crews too inexperienced. Resources too scarce. Doctrine too rigid. Context too desperate. Ship could not fulfill design purpose. Not because design failed. Because everything around design failed. Ship needed experienced crews. Had inexperience. Needed adequate training time. Had insufficient. Needed proper doctrine. Had inappropriate. Needed strategic situation allowing measured deployment. Had desperate emergency requiring immediate commitment. Ship was right. Everything else wrong. Result predictable. American evaluation after war was harsh. Taiho represented Japanese desperation. Building armored carrier while losing pilot training capacity. Building for survivability while losing experienced crews. Building for quality while needing quantity. Correct ship wrong war. Americans built 24 Essex-class carriers. Unarmored. Vulnerable. Cheap. Fast to build. Produced in quantity. Overwhelmed Japanese through numbers. Lost some. Replaced them. Continued. Japan built Taiho. Armored. Protected. Expensive. Slow to build. Produced one. Lost it. Could not replace. Ended. The arithmetic of industrial warfare. Quantity has quality all its own. Taiho was quality. America had quantity. Quality lost. But Taiho's loss was more than arithmetic. Was validation of American submarine doctrine. Fleet submarines hunting capital ships. Albacore was Gado class. Standard fleet submarine. Not exceptional. Not lucky. Not specially trained. Just competent boat with competent crew executing standard doctrine. Doctrine worked. Submarine penetrated screen. Achieved firing position. Launched torpedoes. Hit target. Mission success. Americans lost Albacore 4 months later. Probably mine off Japan. But Albacore's legacy lived. Demonstrated fleet submarines could sink fleet carriers. Demonstrated Japanese carriers were vulnerable. Demonstrated American submarine force was strategic weapon. Doctrine validated. Resources allocated accordingly. More submarines built. More patrols conducted. More Japanese ships sunk. Taiho's loss contributed to this. Proved concept. Justified investment. Japanese drew different lessons. Taiho proved armored carriers insufficient protection. Built Shinano with heavier armor. Sunk by torpedoes anyway. Taiho proved Japanese unable to operate carriers effectively. Suspended carrier construction. Converted incomplete hulls to other purposes. Taiho proved pilot training program failed. Too few pilots. Too little training time. Too much attrition. Could not replace losses. Stopped trying. Taiho proved American industrial superiority overwhelming. Could not match production. Could not match technology. Could not match numbers. Surrendered eventually. Taiho contributed to understanding. Demonstrated Japan could not win carrier war. Could not win any war. Was losing. Would lose. Inevitable. The human cost is measured poorly by numbers. 1,650 dead sounds abstract. 1,650 individuals sounds more concrete, but remains abstract. They were pilots, aircrew, mechanics, sailors, officers, men from across Japan, teenagers, veterans, conscripts, volunteers. Most had families, parents, siblings, wives, children. None would see them again. Ships departed. Ships did not return. Families received telegrams. Your son died gloriously. Your husband died serving emperor. Standard message. Repeated millions of times. War was distant abstraction. Telegrams made it concrete. Empty chairs at tables. Graves without bodies. Memories fading. This was cost. 1,650 families. Experiencing loss. Experiencing grief. Experiencing absence. Forever. The strategic impact exceeded human cost. Taiho's loss crippled Japanese carrier operations. Ozawa lost flagship. Lost command capability. Lost communication capability. Hagura was cruiser. Not equipped for carrier force command. Lacked facilities. Lacked staff space. Lacked communications. Ozawa improvised. Continued battle. Lost. Battle of Philippine Sea ended Japanese carrier aviation. Not just Taiho. Shokaku sunk same day. 350 aircraft lost. Pilots dead. Planes destroyed. Carriers damaged. Force shattered. Japan never recovered. Attempted carrier operations at Leyte Gulf. Used carriers as decoys. Empty carriers. No aircraft. No pilots. Bait for American fleet. Worked. Americans took bait. Sank carriers. But carriers were empty. Already dead. Just moving corpses. Taiho was different. Taiho was alive. Full of aircraft. Full of pilots. Full of potential. Lost to accident. Lost to error. Lost to bad design. Lost to bad training. Lost to bad luck. Loss mattered. Materially. Psychologically. Strategically. Everything. Modern analysis focuses on design flaws. Fuel tank location. Ventilation doctrine. Elevator pit configuration. All true. All important. But miss larger point. Taiho failed because system failed. Not ship system. Institutional system. Training system. Doctrine system. Industrial system. Everything. Ship was symptom, not disease. Disease was Japan losing war. Losing resources. Losing time. Losing personnel. Losing everything. Taiho crystallized this perfect symbol. Built with maximum effort. Maximum technology. Maximum ambition. Lost through minimum error. Minimum luck. Minimum competence. System could not support excellence. Could not support complexity. Could not support survival. System was breaking. Taiho broke with it. First. Dramatically. Catastrophically. But inevitably, everything that happened to Taiho would happen to Japan. Was happening to Japan. Defeat through cumulative failure. Through system collapse. Through inability to sustain effort. Taiho was preview. 8 hours long. Same story Japan would experience. 18 months long. Different scale. Same outcome. The wreck sits 5,500 meters deep. Never located. Never surveyed. Never photographed. Too deep. Too remote. Remains there. Armor plates. Steel structure. Machinery. All corroding slowly. Becoming oxide. Becoming sediment. Eventually becoming geology. Ship returns to Earth, as everything does. 1,000 years hence. Million years hence. No trace will remain. Ship will be gone. Men will be gone. Empire will be gone. War will be gone. Only geology remains. Layers of sediment. Recording moment. Ship sank here. Men died here. Phoenix burned. Died. Did not rise. Name was metaphor. Wrong metaphor. Should have been Icarus. Flew too high. Fell too far. Burned. Drowned. Ended. Great Phoenix. Taiho, built to survive everything. Survived nothing. Lived 3 months. Died 7 hours. Killed by single torpedo. Killed by bad decision. Killed by vapor. Killed by spark. Killed by everything simultaneously. Modern carrier. Advanced carrier. Armored carrier. Dead carrier. Sunk June 19, 1944. Remembered as cautionary tale. About design trade-offs. About doctrine limitations. About training requirements. About system dependencies. About institutional failure. About war's brutal mathematics. About hubris. About fate. About Phoenix that could not rise. Great Phoenix. That burned once. Never rose. Just sank. Taking 1,650 souls with it. Into darkness. Into depth. Into history. into cautionary tale, remembered not for what it achieved, but for what it represented. Japanese carrier aviation dying, Japan dying, Phoenix burning, for last time, for only time, for always.